All right, let's go do some reporting for CISSP. And this thing is a bear, isn't it? All right, so I'm in the data link layer and we're up to segmentation. So let me start my recording for my recording. All right. Okay, welcome back. Let's talk about segmentation. So there's a lot of different things that we've done over the years to segment. But it's not a new idea. This is definitely this easily goes back in time into the 90s, if not before. So we've done things like virtual LANs, which we talked about in a previous video when we were talking about switches. But pardon me. So I'm talking about virtual LANs. All right, let me try this again. All right, so welcome back. I am up to, I'll try that again. Welcome back. Let's talk about our next topic, segmentation. So segmentation is not a new idea. We've been working on segmentation for a very long time. We've talked about a lot of things like virtual LANs, which we talked about in a previous video when we were talking about switches. But this is some newer ideas. To include a dog growling. Stop. Stop. Phineas. Phineas, get down. Get down. Hey, get down. All right, I am trying to get some recording done. CISSP. Oh, hey, is that the same Siri that was here a couple days ago? If so, that's awesome. Oh, wait, I didn't share my desktop. Let me share what I'm doing with you. All right, welcome. So I'm talking about segmentation as the next topic. Did you get a notification that I was online recording? Okay. Here we go. All right, welcome back. Let's talk about segmentation. Segmentation is not a new idea. We've been talking about it for a very long time. We talked about it in a previous video with 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 switches. We were talking about virtual LANs, but this is some newer ideas. Virtual LANs is a form of segmentation, and it was to segment the traffic so that we could control broadcasts. But to get between virtual LANs from one virtual LAN to another virtual LAN, it's really not that hard. All you need is a router. So we need to catch up because that stuff really does date to the 1990s. It's been a while. So there's some newer ideas like microsegmentation. Excuse me. We have some newer ideas like microsegmentation. Microsegmentation is the idea that we can create tiny little networks. To modify our existing networks to do this is going to be very difficult. But as we move into a virtualized environment, as we move to the cloud, private or public, it is easier to build microsegments as we move. So microsegmentation, instead of having a LAN, so a switch and all kinds of different devices plugged into it, and then firewalls and other devices to protect it, why don't we customize things a little bit more? So we could have a switch with a single device, virtual, not virtual, desktop, database, server, whatever it is that we want to isolate because it is of a higher concern for us within our business. We want to protect the data, we want to protect the traffic flow, things like that. And we could actually just build this teeny tiny little network, especially in a virtualized world, very easily. I say very easily, but it depends on skill and how much you're building, I guess. So microsegmentation is just simply that. It's the idea of let's isolate devices virtual in a very tiny little network. That way you can really customize this firewall to the exact traffic that we want for this particular destination. One of the biggest problems with firewalls that we have today is configurations. I mean, it's even arguable. I've had a lot of conversations in CISSP classes. It's arguable if firewalls are even considered a security device. If it's if it's misconfigured in a tiny little way, it is not helpful. So this way we can really customize the firewall exactly to what we need. I had another idea, hypersegmentation. Hypersegmentation really makes things interesting. With hypersegmentation, what we're going to look at is how can we actually control a virtualized environment from one end to another end, literally isolating the traffic flow so it's not visible to anybody else. It's really concentrating on how can we protect our data, especially from hackers. So isolating a traffic flow really gets into a new and exciting idea. New and exciting idea. The protocols we use, you'll see things like 802.1AH, AD, 802.1Q. We get Q to Q, all kinds of fun protocols. For CISSP, we don't have to get into there, but the point is just with that is it's not our traditional Ethernet networking. This is layer 2, so it's all within MAC addresses. Same thing with the microsegments, but it can go up into the IP addressing. But with hypersegmentation, we're at layer 2, and we're going to use things like Fabric Connect, shortest path bridging, SPB, and these other protocols. And with that, it is actually possible to isolate the traffic flow so that it's not visible to anybody else except who's in that traffic flow. SPB itself, shortest path bridging, this thing was actually designed to replace spanning tree protocol, which dates us back to the 1970s or 80s, actually. It really needed some replacement, and we finally have some options. This is one of the options to replace spanning tree protocol. So getting into Fabric Connect and shortest path bridging, I don't think is necessary for this exam yet. Yet, but it definitely could be in the future. But we're not there. I don't think we're there yet. These are newer ideas, and IAC squared does take a little while to catch up with newer ideas. Newer, it's got a few years to it, but this stuff needs to get into the average books that we use to study in order for it to really get into the exam itself. So hypersegmentation is isolating at layer 2, at the link layer, using MAC addresses. It's actually dynamic. It gives a lot of flexibility, so it's not like the traditional configuration of virtual LANs. And it really helps to protect things from hackers. If the hacker can't see the traffic flow, they don't know it's there, they don't know what the destination is, what the source is, they don't know to go after the devices if they get into our network from the inside or the outside. So hypersegmentation, if you like networking, that'd be something to dig into. If you don't, a small idea of it for the test right now, I think is good. It'll be a couple years before this thing actually goes further. And where it would go further is really in the CCSP test and the cloud test, not in CISSP. Okay, bonus for you guys that are here live is I grabbed this screenshot off of Alcatel-Lucent. So it's stolen, giving credit, so it makes it not stolen, but I want to create my own slides for this. So I just put it in here as a placeholder. So we have spanning tree and we have shortest path bridging, SPB, as a difference here. Spanning tree protocol, what it does if you do networking is we have to it prevents loops. And by preventing the loops, it actually shuts down or blocks specific paths across the network. With spanning, I keep saying the S, shortest path bridging. The shortest path bridging, every device becomes its own route. So it builds its own tree on how it's going to get to every destination. Let me change colors here. So this is definitely beyond what you need for the test, but if you do networking it, trying to make sense out of what is hypersegmentation, I think it really helps to have a little more knowledge in there. So unless I create my own slide for this, I'm not going to put it into the course itself. But B5 here would have its own paths. This is at the MAC layer. It's the data link layer. It's not IP based. It would have its own path in order to get to a destination. So it would decide, okay, I'm going this particular path to get to B1, and then it would have another path to get to B4, and it would have another path that it builds to get to B2, and then what am I missing? Oh, B3. So it has its own point of view on everything. Where on spanning tree protocol, you have a root node, and a lot of stuff ends up going through that root node, and we end up blocking off different paths so that traffic doesn't end up in a loop. So cool protocol. New cool idea. All right. So that's a short little recording. Next thing, software-defined networking. And software-defined networking, I need to create another project over here. So give me a second. Okay, new project, new recording. I'll mute myself while I cough there. My voice doesn't want to quite work. My watch just warned me, hey, that's really loud. That's bad for your ears. Well, yes, it is. Okay, so next topic, software-defined networking. Start the recording. Welcome back. Our next topic is software-defined networking, SDN. If I could, if I had a functional voice right now, apparently I haven't talked today. Sorry guys. All right, let me restart that recording because that's just ridiculous. All right, welcome back. Let's talk about our next topic, SDN, software-defined networking. All right, SDN is definitely a newer idea. So this is actually going to tie kind of along the same ideas as hypersegmentation. It's the evolution of networking that we're working our way through from our. We have a lot of 1990s based stuff that we're still using, and it really needs to be upgraded. So software-defined networking. And if you put it in the WAN, we'd call it SD-WAN. If it's in the LAN, it's just software-defined networking. And this can be done in the LAN, it can be done in the WAN, and it can be done in a cloud-based LAN or WAN. With software-defined networking, this is about switches. Switches being layer 2. So this is also not IP-based, as I said, with the hypersegments. Software-defined networking is how can we redesign how the switches are working. And this is also, like I said, with hypersegmentation, this is also designed to replace spanning tree protocol. That protocol that we still are holding on to from the 1960s or 70s. 70s or 80s. I don't know, long time ago. So with software-defined networking, we can finally let that go. And we have a different way for things to work and function. Spanning tree is just for loops, but software-defined networking actually adds a whole lot more than just how can we prevent loops in our switch-based network. Fundamentally, the way I like to look at software-defined networking is we take our switch and we basically chop it in half. We logically have done this in the past. We have our forwarding plane or data plane. We would call it either one. Data plane or forwarding plane, where we just see the user's traffic, the actual user data. And then we have a control plane where any kind of traffic, like traditionally in spanning tree protocol, any traffic that is just for the network itself, just to manage the network, would be on that control plane. Now, planes, if that's a new topic for you, it can seem a little bit weird, I think. With planes, it's not like different planes or dimensions. It's just identifying the traffic as one type of traffic or another type of traffic, and allows us to kind of control how much of each we have, or just be able to identify how much of each we have. A lot of different things we've used it for, but those ideas also date to the 60s and 70s. All right, so with switches, what they are good at is forwarding frames. Very good. They're very good at forwarding frames. What they are not good at is making any kind of decisions, which is why we've had to hold on to spanning tree protocol, because they can easily create loops. If you have a network of switches, so all these being switches, and you have all kinds of different paths to get around that network, you can easily, without spanning tree protocol, pardon me, guys. Usually nobody knows, and I just edit it out of my recordings, but the fun of getting to watch live. But if this is helpful, I'm glad it is. All right, so what was I saying? So if we have a network of switches, it's very easy without spanning tree protocol for a frame to end up going in and ending up in a loop and getting kind of trapped, which is not what we want. So what we want to do is take that switch, divide it in half, and the data plane or the forwarding plane, leave that in the switch. It's good at it. That's what it's designed for. That's what it's optimized for. That's what it's great at. I consider it kind of chop off the brain, have it not making any decisions. What we're going to do is create a controller, which would be a server, not a database. Icon for a database, but I can't draw. So a controller, which is just a server, but with this controller, it is going to control how the network works. So when we have our network of switches in any kind of configuration, with any kind of set of paths, could be that or just about anything else, all of these switches are going to forward frames. That's what it's good at. But if a new stream comes in, so let me change colors for this new traffic flow. If a new traffic flow comes into the switch, so it's going from source A to destination B, if this switch doesn't have any recent memory of how to get to B, what it's going to do is, using the control plane, it's going to send a call over to the controller. Now, the traffic flow actually goes through the switches until it hits that particular server. Just put it off to the side. So it would go through the network. It's not a magical, it's not magical. So controller or control plane, it actually goes by both. So I said control plane and I wrote controller plane. It goes by both. So if it doesn't have any recent memory, the switch calls the controller, and the controller, having full knowledge of the network and all the traffic that's flowing across the network and where destinations are, would make decisions on the best possible path to be able to get to that destination. So what it would then do, we need another color. What it would then do is send out information to the switches that it wants involved in this traffic flow. So it's going to go through these three switches, sends out information, and it would have a temporary path information. So it's going from A to B, and it says go out port number 1. Oh, okay, thanks. I'll go out port number 1, and it just forwards the frame out port 1. When it hits this switch already knows if it's going from A to B, go out port number 3. Why 3? Because that's what I wrote. So it already knows, because when the controller made the decision, it informed all the switches on the path. So this frame then, once it's released, is just going to go very quickly through and be able to get to its destination. So the controller now has the information. The controller is now in control of how the network is going to work and function. So there's not going to be any loops that we have anymore. So you don't need the same physical configuration that we had in the past, and we don't need to worry with configuring the switches with spanning tree protocol, which is a pain in the neck, to say the least. All right, so software-defined networking. Let's see what else. All right, in software-defined networking, we say we have the forwarding plane or the data plane, and then we have the control plane. But there is actually 5 different planes that have been identified in software-defined networking. The application plane, the controller plane, the data plane. Then we have the application controller plane and the data controller plane. The ones to worry about are just these 2, but if you get into software-defined networking, there is a lot more to it. This is just the fundamental basics to it, is data plane and control plane. It's really a marvelous idea. Oh, the other thing, I know what I wanted to add. So the controller, it is controlling things so we don't end up with loops. It decides the path that we want to take. But the other thing that the controller now has the ability to do, because this is a server, so it's up above layer 7. It has all the software capability that we can build into any given server. What we can now do is configure it with policies. We can also teach it about attacks. So when a frame comes in, if it has a particular known signature, we know these attacks, like CISSP likes to mention Smurf attacks and Fraggle attacks. So if it is one of those, it's known and it's recognized, the controller can say, just throw it out. And policy. So if you have any restrictions on your network, if you have times that you want to control things, or specific destinations that you want controlled so that only certain sources can be able to get to those destinations, think kind of like a firewall. So the controller kind of has firewall capability, but it's up above layer 7. It's not a network-based firewall, which gives us more capability as to how to restrict, control, manage our network. So really a cool idea, and it's finally being deployed. It's not a new idea, but it is finally being deployed. There's a lot of major networks out there that are using software-defined networking, and a lot of cloud is building software-defined networking, and as it's being built out as well. All right, so that's the basics for software-defined networking. I will see you in the next video. All right, you guys that are here in the live, do you have questions about any of that? If you haven't, give me a like, give me a follow. I'd appreciate that. Helps me out a little bit. I really want to grow my channel, so the next goal would be to get it up to 10,000 followers. A lot. But I do work in this little subset of the world, CISSP, CCSP, and things like that. Sorry about my voice. All right, so that's 2 for today. Software-defined networking and segmentation. I think that's all I'm going to do. I need to feed the dogs. I have to teach a class starting in an hour, a live class. All right, no questions. No questions. It was nice seeing you again. I will try and get in here tomorrow. Is tomorrow Friday? Where'd this week go? What happened to this week? It's already almost the end of, well, it's halfway through February. What the heck? What the heck? All right, I'm gonna sign off. You guys have a great afternoon. I'm gonna walk the dogs, feed the dogs, get ready for my class. See you tomorrow, hopefully.